In this video, I'm going to cover an example ACT problem where you need to know the rules of exponents. So let's take a look at the rules of exponents. Say for example, I have 2x squared plus 3x squared. Now these are considered like terms, x squared terms. So if I have 2x squared and 3x squared, how many x squareds do I have? I have 5x squared, 5 of them. Okay, so here we just add the coefficients. Now if I have x to the third power times x to the second power, so we're multiplying two variables together. In this scenario, we add the exponents. So we get x to the 3 plus 2 power, or x to the 5th power. So we add exponents when we multiply variables together, and they have to be the same variable, x and x. If there are different variables, then you can't add the exponents together. Now if we have x to the 5th divided by x to the 3rd, so we're dividing the variables. It's going to be x to the 5 minus 3 power, so we subtract the exponents. In this case, it's going to be x to the second power. Now I want to have x to the second power raised to the third power. We're going to multiply the exponents together. 2 times 3, or x to the 6th power. Alright, so those are the rules of exponents. Let's check out an example problem. So here it says, what is the solution set of the following? Alright, so we have 64 raised to the n squared power equal to 16 raised to the 2n plus 2 power. When we have a problem like this, we want to get those numbers, the 64 and 16, to the same base. Now if you know your squares and cubics, 64 is some power of 4. 4 raised to the third power, and 16 is 4 raised to the second power. So we can rewrite these. So this is 4 to the third power raised to the n squared power, and 4 to the second power raised to the 2n plus 2 power. Now using the rules of exponents, 4 to the third power raised to the n squared power can be rewritten as 4 to the 3 n squared power. Just multiplying the exponents together. Over here, 4 to the second power raised to the 2n plus 2 power, I can multiply it by 2. So it becomes 4 to the 4n plus 4 power, multiplied to 2 times the 2n plus 2. Now when we have the same base, 4 raised to something, if these are equal, their exponents have to be equal to each other. So I can set those equal to each other. So 3n squared is equal to 4n plus 4. Alright, so my highest power is the second power, so I'm going to have a quadratic here. I'm going to get all the terms to one side and set the other side equal to 0. So 3n squared. If I subtract 4n from both sides, it will become negative 4n. And subtract 4 from both sides, I get minus 4 equal to 0. Okay, so from here, I can come up with my two factors. Alright, so my leading coefficient is 3n squared. I have a choice of 3n and 1n. My last value, negative 4, that can be 1 times 4 or 2 times 2. So you can just play around with 1 times 4. If I do 3 times 4, that's going to be 12. And I can't subtract enough to get down to the negative 4. So if I try 2 and 2, 3 times 2 is 6, and 2 times n is 2, so 6 and 2, I can get that down to 4. If I make this negative, that'll give me a negative 6, and then plus 2 will give me the negative 4 that I need, and 2 times negative 2 will give me the negative 4 at the end, so that works out. So once you find those, you set each of those factors equal to 0, so 3n plus 2 equals 0, and n minus 2 equals 0. So I'm going to subtract 2 from both sides. It's going to be 3n equals negative 2. Divide both sides by 3. So n equals negative 2/3. Over here, I'm just going to add 2 to both sides. And n is equal to 2. So the solution set to this problem is negative 2/3 and positive 2.